Cyclic quadrilateral ABCD has sides AB is equal to CD is equal to 3 and side DA is equal to 5 with angle CDA is equal to 120 degrees. What is the length of the shorter diagonal of ABCD? Look at the diagram. ABCD is the quadrilateral, that is A, B, C and D, the quadrilateral. Its corners A, B, C and D lie on a circle, which is this circle. Because it is a cyclic quadrilateral, it is further given that side BC is equal to 3, CD is equal to 3 and AD is 5. And it is also given that angle CDA is equal to 120 degree. We have to find out the shorter diagonal of this quadrilateral. Then let us draw the two diagonals AC and BD. Now in triangle ACD, two sides are known, that is side CD is equal to 3, side AD is equal to 5 and the angle between the two sides is also given, that is 120 degree. So we can use the rule of cosines to find out the third side, which is AC. Using the rule of cosines, we get AC square is equal to CD square plus AD square minus 2CD into AD into cosine of this angle, which is 120 degree. So AC square is equal to AD square plus CD square minus 2AD multiplied by CD multiplied by cosine of angle CDA, which is equal to 25, AD being 5 plus 9, CD being 3 minus 2 into 5 into 3 and cosine of 120 degree. Now that is equal to 25 plus 9 is equal to 34. These three things together is 30 and 120 degree is pi minus 60. So the whole thing becomes cosine of pi minus 60 degree. So that is equal to 34 minus 30 multiplied by minus cos 60, which is equal to 34 plus 30 multiplied by half, because minus cos 60 is minus half, and that is equal to 24 plus 15. So AC square is equal to 49. Therefore, one of the diagonals AC is equal to square root of 49, which is 7. Quadrilateral ABCD is cyclic, and the cyclic quadrilateral has a property that sum of its opposite angles is 180 degree. Therefore, this angle plus this angle is 180 degree. This being 120 degree, this angle will be 180 degree minus 180 degree minus 120, and that is equal to 60 degrees. So angle ABC is 60 degree. Now in triangle ABC, that is in this triangle, we now know this side, and this angle. So we can use the rule of cosines again to find out AC, which we know already. to be 7. So let us find this out again. AC square is equal to AB square plus BC square minus 2AB into BC into cosine of this angle. So AC square is equal to AB square plus BC square minus 2AB into BC cosine of angle ABC, and by rearranging terms, AB square is equal to AC square minus BC square plus 2AB into BC multiplied by cos 60, and AC we had found out to be 7, so this is 7 square, BC is 3, so 3 square plus 2 multiplied by 3 multiplied by AB multiplied by cos 60, that is half. So that comes to 40 plus 3AB. By bringing all the terms to one side, we get AB square minus 3AB minus 40 is equal to 0. This is a quadratic equation in AB square. We can solve it in many ways, but for this equation, the easiest now is to factorize, which happens to be AB minus 8 multiplied by AB plus 5 is equal to 0. Please check that AB minus 8 multiplied by AB plus 5 is equal to this, and think about how you can factorize this expression to get this. That is quite simple. Now then we get from this equation AB is equal to 8 or AB is equal to minus 5. But AB is a length, therefore it cannot be negative. Hence AB is equal to 8. Before going any further, please like, subscribe, share and hit the bell so that you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Finally, we'll use Ptolemy's theorem for cyclic quadrilateral, which states that the product of the two diagonals of a cyclic quadrilateral is equal to the sum of the products of the opposite sides. That is, in this diagram, ABCD is the cyclic quadrilateral. The opposite sides, one pair of the opposite side is AD and CB. The other pair of opposite sides is DC and AB. The sum of their product is AB multiplied by CD plus BC multiplied by DA. This sum is equal to the multiplication of the two diagonals, that is AC multiplied by BD. In the present case, therefore, AC into BD is equal to AD multiplied by BC plus AB multiplied by DC. We know that AC is equal to 7. We do not know BD, so let it remain BD. AD is equal to 5, BC is equal to 3, AB is equal to 8, DC is equal to 3, and therefore this right hand side becomes 39. 15 plus 24 is 39. Therefore, 7BD is equal to 39. So BD is equal to 39 by 7, that is 5, 4 by 7. So the two diagonals are AC is equal to 7 and BD is equal to 5, 4 by 7. Obviously, this is smaller than this. Therefore, the shorter diagonal is 5 4 by 7, and that is the answer. Thank you.